Good morning, it's Jeremy. It's Wednesday, December the 21st. Today I want to take a quick look at the Si5351A clock generator. Now recently I've been using the Nano VNA vector network analyzer. It's an incredibly useful instrument. It's very compact and it does many things, and it's a reasonably priced instrument. And I was so impressed with it that I was looking into the circuit diagram. There's a block diagram of the unit, and it uses the Si5351A clock generator. Now several years ago I came out with a series of 0IF direct conversion receivers, and the clock generator module at that time was the Si514, which I used. It only had one output, and then I had to put a divider. So to use it for the HF band, I ran it at 4 times the frequency and used the divider to give me the I and Q outputs that are 90 degrees phase shifted. But when I was using the Nano VNA and I discovered it uses the Si5351, it has 4 outputs, and I realized that it could be used to generate the IQ waveforms quite easily, so I thought I'd better look into it. So the easiest way to get going with a 5351, if you don't want to do a lot of SMT soldering, is to buy a module. And Adafruit has a clock generator module that's got everything on it. It's got the, you can get the 4 outputs, but it's got 3 outputs. You can add an SMA connector to the board, which is probably a good idea. So right now I've connected it to the Arduino. Now Adafruit have a complete manual, schematics, instructions on how to get going, and they've got a sketch software to use for the Arduino, which is really great to get you up and working. So there's the back side of the module. There's basically 4 connections. There's a VCC. The VCC goes to the bottom header here. There's a ground connection which goes there. There's the SDA and SCL, which goes to the top header here. And then I've got a coaxial cable with alligator clips in the end to jumper into, I'm using clock 1 at the moment. And to measure the waveform, I've got the coaxial cable terminated in 50 ohms, and I'm using a picoscope. And for the spectrum analyzer, I've got a DC block and a 20 dB pad. I always put pads in the spectrum analyzer. This is a signal hound spectrum analyzer. The reason I like the picoscope and the signal hound is that they're USB. They're very lightweight and small, and you can put them in, you basically can take them into the field with you, unlike some of the laboratory AC powered legacy instruments, which basically can't go anywhere except the lab. But these things, you can go anywhere. You can even work in Starbucks with them. So let's just quickly look at what we're seeing here. I'm going to switch over to the picoscope. So there's a picoscope display of the Arduino sketch that's loaded from Adafruit. Produces 3 outputs. On output 0 you've got 112.5 megahertz. Output 1 you've got 13.56 megahertz, and output 2 you've got 10.706 kilohertz. Now my picoscope is rated to 100 megahertz, so the 112 megahertz square wave, I'll only see a portion of the primary component. So that's why I'm just showing the 13.56 here, so it looks relatively square. And in the blog post I've got more details about the square wave. And the reason the square wave is important is because when you're using the Nano VNA, it uses all the harmonics, so it can reach up into the L band. So anyways, that's just a quick look at the 5351. Wishing everybody a Merry Christmas and season's greetings.